Have you ever pondered on the existence of rivers beneath the sea surface? Sounds like a riddle, doesn't it? Yet, our planet never ceases to mesmerize us with its awe-inspiring phenomena, one of which is the enigmatic underwater rivers. Picture this, a river, flowing not across the Earth's surface but beneath the ocean's waves, carving out intricate pathways in the seabed, much like their terrestrial counterparts. Paradoxical as it may seem, these aquatic marvels are as real as the rivers we see on land. They're formed by the movement of denser, sediment-laden water through the less dense seawater, creating a spectacle that's as mesmerizing as it is complex. From the Monterey Canyon off the coast of California to the world's largest underwater river located beneath the Amazon, these subaqueous rivers are a testament to the Earth's dynamic and ever-evolving nature. Join us as we delve into the fascinating world of underwater rivers. Underwater rivers don't just appear out of the blue, they are the result of intricate geological processes. These phenomena, as surreal as they sound, are formed due to the interplay of varied factors such as salinity, temperature differences, and sediment flows. To understand how underwater rivers are formed, let's first look at the role of salinity. Salinity, or the salt concentration in water, plays a crucial part in creating these underwater rivers. When seawater mixes with fresh water from sources like rivers, the resulting mixture, called brine, is denser due to its higher salt content. This brine, being heavier, tends to sink and flow along the ocean floor, much like a river coursing through a valley. Now let's talk about temperature. Cold water is denser than warm water. So when cold seawater encounters warmer seawater, it sinks and flows along the bottom of the ocean, carving out a path similar to a river on land. This process is another way that underwater rivers are formed, but there's more to the story. Sediment flows also play a significant role in the formation of these rivers. Over millions of years, sediment from the land gets washed into the sea by rivers. These sediments, which include everything from sand and silt to pebbles and organic matter, gather and flow along the seafloor. Over time, these sediment flows carve out valleys and canyons in the ocean floor, resembling the river systems we see on land. These underwater rivers are not stagnant entities, they continually evolve, shaped by the forces of salinity, temperature, and sediment flow. And they are not limited to certain parts of the world. From the Monterey Canyon off the coast of California to the undersea stretches of the Amazon, Congo, and Yenisei rivers, these intriguing phenomena can be found across the globe. So, the next time you imagine a river, don't forget the ones flowing beneath the sea. These invisible rivers beneath the waves are as real and as majestic as the ones we see on the surface. They are a testament to the intricate and awe-inspiring processes that shape our planet, both above and below the ocean's surface. Underwater rivers are not mere replicas of their surface counterparts. They boast unique attributes. Delving into the depth, length, and speed of these subaqueous rivers, we find a fascinating world that pushes our understanding of rivers beyond the familiar. Underwater rivers, or submarine channels, can reach incredible depths. Some, like the Congo River's subsea extension, can plunge to nearly 700 feet below the surface. Others, such as the Canyon submarine off the Bahamas, are thought to be over 4,000 feet deep in certain spots. These astounding depths are a testament to the power and persistence of water, carving its path even in the depths of the ocean. But it's not just the depth that sets underwater rivers apart, their length is equally impressive. The Monterey Canyon off the coast of California stretches for about 200 miles, while the Hudson Canyon off the coasts of New York and New Jersey extends for approximately 250 miles. These undersea rivers are not short-lived streams, but enduring channels whose formation has taken millions of years. And then there's the speed. Underwater rivers don't meander languidly, they flow with surprising vigor, driven by gravity and the density of the sediment-laden water they carry. These rivers can move at a speed that rivals and sometimes surpasses their counterparts on land. This speed, combined with their depth and length, enables them to transport vast quantities of sediment and nutrients across the ocean floor. What makes underwater rivers even more intriguing is their ability to foster life. Despite the challenging conditions, these rivers provide essential nutrients to a variety of organisms that inhabit the ocean floor. Yet, despite these unique characteristics, underwater rivers share a fundamental trait with their terrestrial counterparts. They are both shaped by the constant, relentless action of water and sediment, carving their way through the landscape, whether it's made of rock or ocean floor. Underwater rivers, with their unique traits, add another layer to our understanding of the world. Our planet is not just a sphere of land and water, but a complex, interwoven tapestry of diverse ecosystems, each with its own unique characteristics and inhabitants. Underwater rivers are not just geological curiosities, they play a crucial role in our ecosystem. Indeed, these submerged waterways are more than just fascinating features of our planet's underwater topography. They serve as vital arteries, transporting nutrients and sediments across vast oceanic distances. Just as rivers on land help support a diverse range of ecosystems, underwater rivers play a similar role in the deep-sea environment. Much of the life on the ocean floor depends on nutrients from the surface. These nutrients often find their way down through detritus and marine snow, but underwater rivers can also play a key role. These submarine channels carry nutrient-rich sediments from the land, dispersing them across the ocean floor. The nutrients they transport support a wealth of marine life, from microscopic organisms to large deep-sea creatures. Furthermore, underwater rivers are integral in shaping the seafloor. The movement of these rivers, driven by gravity and the density of their water, can carve out vast canyons and create expansive plains. Much like their terrestrial counterparts, they erode, transport and deposit sediment, altering the landscape over time. This process contributes to the diverse topography of the ocean floor, creating habitats for a myriad of marine species. Underwater rivers also play a significant role in global nutrient cycles. They transport carbon, nitrogen and other elements from the land to the ocean, helping to regulate the Earth's climate. These elements are then used by marine organisms, which in turn contribute to the food web and the cycling of these nutrients. Moreover, the study of underwater rivers can provide valuable insights into our planet's past. The sediments they carry are like pages in a history book, telling a story of climate change, tectonic activity, and even ancient civilizations. By studying these sediments, scientists can learn more about how our planet has evolved over millions of years. Indeed, the significance of underwater rivers extends far beyond their mysterious allure. These hidden waterways are integral to the health of our oceans, the diversity of marine life, and our understanding of Earth's history. As we continue to explore and study these underwater rivers, we are reminded of the intricate and beautiful complexity of our planet. Let's take a journey across the globe to visit some of the most notable underwater rivers, beginning with the Monterey Canyon, an undersea river sculpted over millennia by sediment flows. Nestled off the coast of California, this marine marvel stretches roughly 200 miles, carving a path deep into the ocean's abyssal plain. Now we venture to the heart of the Amazon, the world's largest river by discharge volume and second longest. Its undersea counterpart runs along the ocean floor, transporting vital sediment and nutrients to the creatures that dwell beneath the surface. We then traverse to Africa's second longest river, the Congo. Boasting depths of nearly 700 feet, its underwater river mirrors the terrestrial one, providing crucial nutrition to the organisms that inhabit the deep. Our next stop is the Canyon Submarine, located off the coast of the Bahamas. This underwater river, one of the world's largest, stretches over 70 miles, and is thought to plunge over 4,000 feet deep in certain spots. Let's not forget the Hudson Canyon, off the coasts of New York and New Jersey. This colossal underwater river stretches approximately 250 miles, and is reported to descend over 7,000 feet in some areas. We then dive into the Bengal Submarine Fan, a massive underground river in the Bay of Bengal. It extends roughly 1,800 miles and is reported to be more than 15,000 feet deep in certain spots. We also have the Ganges Brahmaputra and Indus Submarine Fans, both located in the Bay of Bengal and Arabian Sea respectively. They stretch for about 1,200 miles and are reported to be over 12,000 feet deep in parts. Finally, we reach the Nile Submarine Fan in the Mediterranean Sea and the Yenisei River in Russia. These impressive underwater rivers also contribute significantly to the ocean floor's ecosystem. These underwater rivers stand as testament to the unending wonders of our planet. Our exploration of underwater rivers has been a deep dive into an intriguing aspect of our planet. We've journeyed through the formation of these aquatic marvels, carved over millions of years by sediment flows that journey thousands of miles from land. We've examined their characteristics, from the world's largest river, the Amazon, with its own undersea river, to the deepest, the Congo, nourishing life in the ocean depths. We've looked at the significance of these underwater rivers, vital nutrient highways for marine life, and we've explored examples from the Monterey Canyon off California to the Bengal Submarine Fan in the Bay of Bengal. Intriguingly, we've also discovered that even the fifth longest river in the world, Russia's Yenisei River, has an undersea counterpart. So, while the mystery of underwater rivers unravels, remember there's always more to learn about the world beneath the waves.